In this video, we are going to learn about conversion factors and measurement. How a measurement and conversion factor are related. Before we talk about conversion factor, let's talk about measurement. Now, a measurement is a value that is defined by a number and a unit of measurement. One common measurement that you use every day is $1. Notice how the word dollar is functioning as a unit of measurement, and then the number 1 indicate a values. So $1 is a measurement that defines a specific amount or values of money. Now let's go back and talk about conversion factor. A conversion factor is a ratio, or basically a fraction, of two numbers with different units, but their values are equal to each other. That is, their values are equivalent. Now, going back to money, one of the common conversion factors that we know is $1 equal to 100 penny. Notice how the unit dollar and the unit penny define the values of the number. In this case, we have 1, but defined by dollar equal to 100 penny. So the unit penny indicate a very small number, where the unit dollar indicate a larger values. That's the reason why $1 is equal to 100 penny. So again, the unit has a values as well as the number. When you combine a number and a unit, you have a measurement. When you combine two measurements that of the same values, it doesn't matter they have different unit, we have a conversion factor. And what can we do a conversion factor? We can now convert between two different units. So we can multiply a measurement by a conversion factor or a series of conversion factors to change one unit of measurement, that is to change from dollar to another unit measurement to penny in this case if I want to. But in chemistry it gets more complicated than dollar and penny. But the key part is that you are changing the unit without changing the values of the measurement. So how does that work? Notice this is $1 equal to 100 penny. That can be represented as $1 over 100 penny. Or it could be 100 penny over $1. Why is that possible? Because they are equal to each other, therefore they equal to 1. And if you multiply anything by 1, it's equal to itself in terms of the values of it. And that is the beauty of a conversion factor. It is equal to 1, and therefore you can change from one unit of measurement to another unit measurement without changing the values. So let's look at some of the most common conversion factor and some of the complicated conversion factor that you will see. But the key part is that you don't have to come up with a conversion factor. It is always given to you. So here are the common conversion factor that we are going to use. So here are the common conversion factor in relative to money. We have $1 equal to 100 penny, 1 quarter equal to 25 penny, or 1 dime equal to 10 penny. Notice we don't care about the plural form of the unit, because sometimes adding the plural form will change the spelling, and therefore it changed the structure of the unit. So penny is remaining as singular, as well dollar, quarter, and dimes. So keep that in mind. Don't let the plural form in the question trick you. Then over here we have 1 liter equal to 10 to the third milliliter. Now what is 10 to the third? 10 to the third is basically just 1,000. So we can have 1,000 milliliter equal to 1 liter. So the number itself can be represented in different format. It doesn't really matter. A number is still a number. It doesn't matter how it looks. The value is still the same. The same thing with kilogram. I have 1 kilogram, which is equal to 1,000 grams. But instead of writing as 1,000 grams, sometimes I will be given as 10 to the third. And 10 to the third is equal to 1,000. Then over here I have more complicated conversion factor that you have no idea what it's about. It doesn't really matter as long as you keep in mind that a measurement is defined by a number and a unit. And a unit doesn't have to be one word, it could be multiple words in this case. In this case, we have 1 mole of carbon. So we have the identity of a substance in chemistry, and here we have the unit mole. So mole is a unit as much as grams or penny or quarter, where in chemistry we have specific substance. In this case, we worry about or we talk about carbon, and 1 mole of carbon is equal to 12 grams of carbon. And notice the gram is the unit, where the carbon is the identity of the substance. So don't get confused with carbon as a unit, but carbon is now part of the unit because we are talking about moles of carbon. Because down here, you can talk about moles of C, which is carbon, and then all of a sudden we have moles of carbon dioxide. Is moles of carbon dioxide and moles of carbon the same thing? No, their identity need to be the same. Okay, so once you change the identity of a substance in chemistry, you also change the value as well. And that's the reason why we need to learn the chemical formula of each different substance. Because different substance is now being defined by a specific unit, or a specific unit is defined by a specific substance. For instance, we compare moles and grams, right? Here we have moles of carbon, but we also have moles of carbon dioxide. And down here we have moles of calcium carbonate, or we have moles of oxygen by itself. And then we also have another unit called atom, and the identity is carbon. And down here we have another unit called formula unit. Then we have another identity, calcium carbonate. Overall, it doesn't matter how complicated it looks, but in the end, as long as you realize that a measurement is defined by, first of all, a number, followed by a unit. In most cases, it is followed by the identity of a substance. It doesn't matter what unit it is, it still functions the same way as any conversion factors. Are we ready to try one problem together? Let's start with an easy problem first. Let's start with 2 easy example problems first. How many pennies are there in 5 quarters? First of all, we need to start with our given information. In this case, we know that we have 5 quarters, but we are looking for how many pennies. So we can think of 5 quarters. Notice how I underlined the whole entire measurement, which is a number followed by a unit. So 5 quarters, but we wanted to find how many of penny are in 5 quarters. So we can find of this as a number, which is a question mark of penny. Okay, we call this given as given information of what we have, and we call this the unknown, which what we are looking for. So U represent unknown, G represent given, and we always start with our given. So in this case, we are given 5 quarters. And going back to this, all we have to do is to find the right conversion factor to multiply by our given to convert from one unit to another unit. And we go back to our list of conversion factor. Which of the conversion factor has the given unit as well as the unknown unit? So that's a trick. You have to find the right conversion factor to use. But the beauty part is all the conversion factor is given to you in this case. So I'm looking for quarter and penny, and there you go, we have quarter and penny. And I notice, hey, 1 quarter equal to 25 penny. Now I'm going to multiply by that conversion factor, and I'm going to say, hey, I'm going to multiply by this conversion factor. 1 quarter is equal to 25 penny. And that's it. That's all you have to do. The only thing left is, but the last thing we have to do is multiply this as a fraction or a ratio, because this is a conversion factor. We cannot just multiply a conversion factor like this. We have to convert into a fraction. So how do we convert this into a fraction? We just take our given 5 quarter time Notice there are two parts, one with a quarter and one with a penny. They are two different units. The tricky part is what unit go on top and what unit go on bottom. Remember, we want to cancel out, or we want to get rid of quarter to figure out a penny, right? And that is the reason why this unit will always be the one on the bottom as well. So this is also the previous unit as well. In this case, the previous unit is quarter. So down here must be quarter. So here we have 1/4. Okay? And this part of the conversion factor is on the bottom of the fraction. The top part of the fraction must be the leftover. In this case, it's going to be 25 penny. And notice how we cancel out quarter. Think about it. How does this cancel out? Remember in your math class where we have x and x? Notice how the x cancel each other out? Because the unit or the variable is the same, give us 1. The same thing in this case, quarter over quarter cancel out equal to 1. So what we have left is the penny. Now we can simplify this. We have 5 times 25 penny over, notice how we have 1 right there, and give us a total of what? 5 times 25 is 125. So it's 125 penny over 1, which is equal to itself. So therefore, in 5/4, we have 125 penny. So that is the beautiful concept of conversion factor. Notice the values of 125 penny is the same values as 5/4. Now, remember, part of this is talking about a series of conversion factors as well. Sometimes the problem is really easy when we only have to multiply by one conversion factor. What happens when we have to multiply by a series of conversion factors? Let's try one problem that we had to multiply by more than one conversion factor. First of all, let's look at the problem. How many dimes are there in 5/4? The same problems, okay? Except now we're not looking for penny, we're looking for dimes. We don't have a conversion factors right here that relate quarter and dimes. We don't have a conversion factor that relate quarter and dimes, but we have two conversion factors that relate quarter and dime. This one has quarter and penny, and then we have penny to dime. So by using penny in the middle, we can now convert from quarter to dime. So let's describe our relationship between quarter and dimes. First of all, we know that quarter is related to penny. And then we know that penny is related to dime. Because they are being now connected by penny, we can now solve from quarter to dime. So how does that work? All you have to take your given quarter, which is 5/4, time the conversion factor that relate quarter and penny. In this case, 1/4 equal to 25 penny. And then time another conversion factor that relate penny and dime, which is 1 dime equal to 10 penny. Now we have a relationships of quarter, penny, and dime that describe with a specific conversion factor. We just have to multiply the given by the conversion factors that's involved. In this case, we have 5/4 times the first conversion factors again. Since this is quarter must be on the bottom of the fraction as well. So this part is gonna be on the bottom. So we have 1/4. And if this part is on the bottom of the fraction, the other part of the conversion factor must be on top. So 25 penny must be on top. And notice how we cancel out quarter right away and give us penny, right? So let's continue on. We don't worry about the math yet. Let's save that later. We multiply by the next conversion factor. In this case, it's this one right here. Notice how we have penny as the unit that's being previous of this one. So we look at this conversion factor, penny must be on the bottom. So therefore we have 10 penny on the bottom of the fraction. If the 10 penny on the bottom of the fraction, the other part must be on top, which is 1 dime. And there we go, we multiply our two conversion factor as a fraction. Notice how quarters cancel out as well as penny. So give us our only unit dime, which we are looking for, and of course this is our unknown and this is our given as we stated earlier. So in this case, we would have 5 times 25 times 1. Basically, you take all the number on top of the fraction, you multiply them together. 5 times 25 times 1 dimes divided by all the number on bottom. In this case, the number on the bottom are 1 and 10. So 1 times 10. And pretty much this is our answer if we don't simplify. But if we want to simplify this and get our final answer in terms of exact number of dimes, we can just plug in a calculator. 5 times 25 times 1 divided by 1 divided by 10. So again, multiply everything on top, divide everything on the bottom, and give us 12.5 dimes. So 12.5 dimes has the same values as 5 quarters.